We are continuing with 9.1, Chapter 9, review worksheet number 1. This is the back page. Number 20, f of 0 equals 0, f prime 0 is 1, f double prime 0 is 0, f third derivative at 0 is 2, which of the following is third order Taylor polynomial generated by f of x at x equals 0. We're given a lot of information, so we don't have to technically build our third order Taylor polynomial. But we can always refer back to our Taylor rule here, which is the nth derivative evaluated at c, our center, over n factorial times x minus our center raised to the nth. So we can build this after the first two terms. The first two terms is simply just a tangent line, writing the slope of the tangent line, or equation of the tangent line. So which is y sub 0, which in this case is 0, and then the slope times x minus x sub 0. So x sub 0 is at 0, and our slope is at 1. So that's the first two terms. And then we can build starting with the second derivative. So second derivative evaluated at the center is 0 over 2 factorial, because this is when n is equal to 2. X minus our center raised to the second power. Okay, plus, and now the third derivative evaluated at 0, a center 0, is 2 over 3 factorial times x minus 0 to the third power. And if we simplify this expression, we know the zeros will cancel out. We're left with x plus 2 over 6. 3 factorial is 6, so 2 over 6 is 1/3, x cubed. So E. Okay, 22. Which of the following is the coefficient of x to the fourth in the Maclaurin polynomial? So this, we probably do need to build our Taylor polynomial here, our Maclaurin polynomial. So we're going to go through our steps to find the fourth derivative, work our way down to the fourth derivative of cosine of 3x. So we know that f of x is cosine 3x, f prime is cosine of u times u prime, so negative 3. The derivative for cosine of u is negative sine of u times u prime. And since our u value is 3x, our u prime is negative 3. And the derivative of sine is cosine. And then again, the u prime, so we multiply by 3 again. Multiply by 3, multiply by 3. Cosine becomes, negative cosine becomes sine, and then sine becomes cosine. So here we have all four derivatives evaluated. So now we just have to evaluate them at 0. Okay, so what is the following is a coefficient of x to the fourth. X to the fourth is dealing with 81 cosine of 3x. So this is the rule. We want to evaluate the fourth derivative at 0 over 4 factorial times x minus 0 to the fourth, since our center is 0, given that we're dealing with the Maclaurin polynomial. So the fourth derivative is 81 cosine of 3x. Evaluated at 0 would mean that we plug 0 into the fourth derivative. So 81 cosine of 0. Cosine of 0 is 1, so 81 times 1 is just 1 over 4 factorial. And if I just clean this up, 4 times 3 times 2 becomes 24. 81 divided by 24 is 27 over 8. And then x minus 0 to the fourth is simply x to the fourth. Coefficient is everything in front of the x to the fourth, so therefore 27 over 8. Choice A. 22. Which of the following is Taylor polynomial generated by cosine of x at pi over 2? So let's go ahead and build our Taylor polynomial by finding our derivative down to the fourth degree, since these are either the third or fourth degree here. So f of x is cosine, so therefore f prime is negative sine, f double prime is negative cosine, then becomes sine, and finally it becomes cosine. So we're just evaluating each derivative by finding the derivative of each term, and then evaluating them at our center, which is that pi over 2. So cosine of pi over 2 is 0, negative sine of pi over 2 is negative 1, negative cosine of pi over 2 is 0, sine of pi over 2 is 1, cosine of pi over 2 is 0. So if we build our term here, is y sub 1 minus m times x minus x sub 1. So we're taking our ordered pair here and our slope, and creating our first two terms, and then from there we can go to our second derivative, which is the second derivative evaluated at 0 over 2 factorial times x minus the center squared, and then third derivative evaluated at 0, which is 1 over 3 factorial times x minus the center pi over 2 cubed, and finally 0 over 4 factorial times x minus pi over 2 to the fourth. But what we're going to see is if we try to build our fourth derivative, we're going to see that it will cancel out to be 0. So we know this term drops out to be 0. We know this term drops out to be 0. First term is 0. So we're just left with the portion that is associated with the first degree and the third degree. So negative x minus pi over 2 plus x minus pi over 2 quantity cubed over 3 factorial. So that matches choice E. Okay, which of the following gives Maclaurin polynomial of order 5, approximation to sine of 1.5? So we are dealing with sine of x. So we can build the Maclaurin polynomial for sine of x down up to the 5th degree. So sine of x we know is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. So that's something that we need to be able to memorize, so we don't have to build these commonly used Maclaurin polynomial over and over again. So once we have, remember this is not 5 terms, this is asking for the 5th degree, so we're stopping at the 5th degree, 5th order. Now here we have our Maclaurin polynomial. We just have to plug in 1.5 for each of the x's and then use our calculator to find the approximation. So 1.00078, which is equivalent approximately to 1.001. Okay. Which of the following is the quadratic approximation for e to the negative x at x equals 0? So e to the negative x, we can build our Maclaurin polynomial up to the 2nd degree. So we know e to the x is 1 plus x squared over 2 factorial. So e to the negative x just means that we can replace every x we see with negative x. So 1 plus negative x, or 1 minus x, plus x squared over 2. And here we have quadratic approximation means that we're stopping at degree 2. So that's our 2nd degree, and that's where we stop. So 1 minus x plus 1/2 x squared.